Hey guys, welcome to example 9 of 9.1. We've got Armando's Pizzeria offering patrons any combination of up to 10 different toppings. In this case, if you think about toppings, the order in which you put the toppings on shouldn't really matter. So for A, if we can choose any 3 toppings, that means we have 3 spots. So this would be 10 things to choose from. It's going to be a combination because the order doesn't matter, how you put the toppings on. And 10C, we got 3 to choose from. And if we're doing this by hand without a calculator, it's pretty easy because the numbers are small. It would be 3 spots, 1, 2, 3. You can use the formula as well, but I'll just include the R factorial that I said was the extra bit. So it would be 10 times 9 times 8. So that's a permutation so far, but within the 10 times 9 times 8 arrangements, there's going to be pizzas with the same toppings, just in a different order. Well, how many times did that increase? How many duplicates are there in that case? And that would be 3 times 2 times 1, right? That's that R factorial. So we're going to divide out and remove all those duplicates. And so that'd be 10, 9, 8, 3, 2, 1. And it's nice that we can just sort of cancel things out. And this would just be 120 pizzas. All right, that's part A. So pretty straightforward there. Part B is a little tricky because, well, it says if we can choose any number of toppings, 0 through 10, that's kind of a problem. It's very doable. We're still going to use combinations. However, the problem is this. Well, let's say we can pick 10 toppings. Well, then that'd be 10C, 10, right? That's going to give me some number. But then, well, what if I want 9 toppings? Well, it's going to be 10C, 9. And then 10C, 8. And all the way down to 10C, 0, actually, because we can have no toppings, right? And what do we do with all these numbers? We're going to add them all up. That's a lot of work. So we're going to look at another way to look at these problems, which is a formula for counting subsets of n set. And there are 2 to the n subsets of a set with n objects. Now, this is kind of a fancy mathematical way of describing a scenario where you have a yes or no situation. Yes pepperoni, no pepperoni. Yes sausage, no sausage, right? And the reason why is because when you say yes or no, those are 2 possibilities. And if you think about a branching diagram, right? Yes or no to sausage, right? Yes or no to pepperoni. Yes or no to onions, right? As you can see, I can keep doing this, but every time I introduce a new topping, whoops, get rid of that. Every time I introduce a new topping, I'm doubling the number of possibilities, right? So each one of these branches counts for a different combination of topping. So it's just 2 times 2 times 2 times 2 because, well, that's how, we go by how many toppings we have in this case. So in this case, we have 10 toppings. This would just be 2 to the 10, and that's, I believe, 1,024 pizzas. So you can do that instead. All right. And that's it. I believe the only other thing we have to do is example 10, and we'll be done.